Hello everyone, this is Catalin from the Coding Cave and welcome to another data science tutorial. In this tutorial we are going to start to talk about statistics. More specifically, in this episode we are going to talk about measures of central tendency. So let's get started. So when we have a large amount of data, we usually need to find out around which value our data is centered, and there are quite a few ways to do that, which are called, you get, measures of central tendencies. So the first concept I'm going to introduce is the concept of mean. So the mean or the arithmetic mean is computed summing all the values in our database, so all the values or all of our data, and then dividing it by the size of our data. Uh, this is the mathematical formula here. For those who don't know what this symbol is, this symbol is called sigma, and it is used to describe a summation in mathematics. This is another way to write the formula of the mean in mathematics. So you add each element in your list, in your data list, and then you divide everything with the number of the elements in the list. So let's try to write that in Python code. It is very simple. So let's see here. Let's define a function called mean, which will take a vector of values called x, and it will return the sum of x divided by the length of x. Here I have a data set which represents the scores the people or the students in a class managed to get. Sorry. So they range from 1 to 10, 10 being the highest score and 1 being the lowest score. And let's try to find out the mean of our data. And let's print it. And as you can see, this is the mean or the average of our data, 6.21, and some more decimals there. Uh, Pretty basic, pretty obvious. Now let's start explaining the next concept. So the next function I'm going to talk about is the mode function. So what is the mode? So basically the mode of a data set is the value which appears most of the time. So for example, if we have some list of numbers, let's say 1, 2, 2, 3, 4, then the mode of this list or this data set is 2 because each number appears one time except for 2 which appears 2 times. So the mode of this list is going to be 2. Now let's try to write a function to mimic that behavior. Uh, Here is another example of the mode. So here we have this list, 1, 2, 2, 2, 3, 3, 4. So 1 appears one time, 2 appears 3 times, 3 appears 2 times, and 4 appears one time. So 2 appears has the most frequency of appearance or appears most of the time. So the mode of our data set is 2. So let's try to write that in Python code. So our mode function is going to take a list of values as a parameter and is going to return the value which appears most of the times. For that, we are going to use a function called counter. So just import the following library. So from our module. So from collocation, import everything. And now we can use counter. So let's see here. Let's call it frequency dictionary, and we will use counter of text to create it. So for those who don't know, counter is a function which takes a list and returns the dictionary with the frequency of each element in that list. So let's return the frequency dictionary first in order to see what I mean, and let's just print mode of data. So as you can see, the score 7 appears 7 times, 8 appears 4 times, 3 appears 4 times, 9 appears 4 times, 5 appears 4 times, 10 appears 3 times, and so on. So basically a counter, or the counter function, returns a dictionary where the keys are the values in the list, so these values, and the counter, or the elements in the dictionary, or the elements the dictionary maps to, are the frequency of each, is the frequency of each element. So how many times each element appears. uh, so far so good. Let's continue with our mode function. So now we need to find the value which appears most of the times. Let's call it max value, and it is going to be equal with max of frequency dictionary dot value. So the dot values function uh, returns us the values of the list with all the values in our dictionary. So 7, 4, 4, 4, 4, 3, 2, 2, and so on. And then the max function is going to return us the maximum value of that list. And now let's return a list with the elements which appear most of the time. So to do that, let's iterate through our dictionary. So we'll use list comprehension here. So we'll return x for x, y in frequency dict dot items if I equals with the max equals max value. So what we do here is that we iterate through both of the values in our dictionary, both the keys and the values, and then if the value is equal with the maximum value of our dictionary, then we put x into the list. So the final list is going to contain the keys of the dictionary, uh, 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 which have the maximum values, or the which correspond to the maximum values in the value list of the dictionary. If I am clear, I hope I am. So you will be able to understand it once we run the program. So because 7 appears 7 times, the mode function will return 7, but let's say that we change 3 of the 7s with 6, and now with, let's see, 10s, 10 and 10. Yeah. So let's put some zeros here. So now, as you can see, there are more values which appear. Well, all these values 8, 3, 9, 7, 5 all have the same frequency. So the mode of our dataset is the list containing all of the values. Now the next concept we are going to learn about is the median. So what is the median? So the median. I have a few images to illustrate that. So the median is the central value in our sorted dataset. So if we sort our dataset, then the median is going to be the value which is mm, uh, or under the basically under the median 50% or 50% of our data lies under the median and 50% of our data lies above the median. So in case of even number of or an odd number of elements in a data set, the median is basically the middle value. So we sort the data set and then we take the middle value, which is the median. So in our case, we have the data set 1, 3, 3, 6, 7, 8, 9, and the middle value in this list of numbers is 6. So the median of this data set is 6. Now, in case of an even number of elements, uh, what we do is that we take the two values which are in the middle, because this data set doesn't have a single middle. There are two middle values, and then we take the arithmetic average of these values, and the median is going to be that average. So under 4.5, 50% or approximately 50% of our data is below and 50% of our data is above. Let's now try to this is another very representative image of the median. So now this is the middle value, the median. 50% of the data is below the median and 50% of the data is above the median. So this is another very good or very representative image. So let's try to implement that in Python code. So firstly, we are going to need to sort the list of numbers. For that, we are going to use the sorted function. So sorted x is going to be equal with sorted of x. Now n is going to be the variable which contains the length of our list, and now if n is odd, then we just return or not then we just return the middle point. So we will return sorted of x divided by 2. Else, if the number of elements in the list is even, we are going to return the average. So the middle point is going to be x divided by 2. Then we are going to return sorted x of mid plus sorted x of mid minus 1 and divided by 2. And let's don't forget to return the value. Now let's try to compute the median of our dataset. So let's print the median of data. And let's compile it. Let's see here on support. Yeah, because we have to put n in here. Yeah, well, let's just use the simple division. So let's see here. Let's do that because the indices should be integers. And now, as you can see, we have returned the median of our data, which is 6. So our data set has 32 values. So we will, we will go to, we are going to use this branch, or we used this branch, and now we have computed the median, which is 6. Now, a more generalized concept is the quantile. So what is a quantile? So a quantile is the value beneath a certain or a specific percentile of the data lies. So the median is the 50% quantile, but there are other types of quantile. For example, if we have to find the value under which 40% of our data lies, then we are going to compute the 40% quantile, and to compute the quantile, it is very easy to compute a quantile. We can just do the following thing. So we have quantile, which takes the data set and the percent. The index is going to be uh, the percent times the length of our data set, and we will just return. Firstly, we have to sort our data set. So x or sorted x is going to be sorted of x, and now we are going to return the sorted of index. So let's find out the 25 or the 25% quantile of our data set, and let's print it. So data and 0.25. So let's see here. Well sorted x. Now here is our value. So the 25% quantile of our data is 3. Now if we want to find out the 75% percentile, we just use 0.75, and as you can see, the 75% quantile of our data set is 8. So what that means is that under the value or under the score of 8, 75% of all the scores lie. The half quantile is 6. So the median is basically the 0.5 or the 50% quantile. So the quantile is a more generalized the median is a particular case of the quantile. The quantile is a more generalized concept than the median. And that was it for central tendencies. In the next episode, we are going to continue talking about statistics. We are going to talk about dispersion. I hope you have enjoyed the video. Don't forget to like and subscribe. Don't worry about the dataset here, because I'm going to post this code on my website, so you can just copy the data from there. Don't worry, you don't have, you won't have to write all these 32 values manually, because it is just a waste of time. You can come up with your own values, or you can just copy mine from the code I'm going to put on my website. So as I have said, Thank you for your attention. I hope you have enjoyed my video. Don't forget to like and subscribe, and see you in the next episode. Bye.